Alright, good day everyone. So welcome back to my YouTube channel. This is Kasaligan Vlogs. And today we will be talking about the volume of a solid revolution. And this now, the method that we're going to use is the washer method. So learning outcome, at the end of the lesson, you will be able to compute the volume of a solid revolution using the washer method. Right, so let's talk about washer method. So let's consider the graphs of the function f and g and the region bounded by the two functions, and the line h is equal to a and h is equal to b. Raise 1. So this is the two function f and g, which is has the two functions, the lines h and b. This region is to be rotated, along the line H, and the solid is generated, this one. If the area bounded is revolved around the line H, this will sweep out a washer-shaped solid where the volume of the solid is difference between the two circular discs. Okay, this is the difference between the two circular discs here, this one. So this is the two circulars, the difference between the two circular discs. If we're going to make this one. And the volume of the larger solid can be denoted as this one. The volume of this one, dv2 is equal to pi r squared dx, and the smaller one is dv1 is equal to pi r squared 1 dx. Then the volume of the washer is, this is the difference. Okay, dv is equal to difference of the derivative of volume 2 minus dv1. So dv, the derivative of the volume or the washer using the washer method is equal to pi r squared times change of h, that is 2 minus pi r squared change of x. This is the radius is 1. So this is the difference between the two circular. So this is dv2 minus dv1. Hence, the volume V of the solid is the sum of the volumes of the washers generated, and by the definition of different integral, the volume V of the solid will be this one. So V is equal to, using the previous lesson, but this is now the difference of the two circular discs. So two circular discs here. So V is equal to pi r squared 2 minus r squared 1 dh times dh from A to B. So this is the formula for the washer method. So let's have problem number 1 for washer method. Find the volume of the solid generated by revolving about the y-axis. This one is the y-axis, bounded by x squared, y is equal to x squared, and x is equal to 2. So when x is equal to 2, the point of intersection is this one, 2 and 4. And along y is equal to 0. So what we're going to do here is, if we're going to take this one and revolve with a y-axis, it forms like this. It's a washer. It generates a washer, look like. So this one is from here, this is x, the value for this one is 2, and from here the value is equal to x. That's why r here, the first r is equal to 2. This is the bigger r, and the one is r1. So this is our r2, and this is our r1. So to get the volume is equal to pi, that is r2 squared minus r1 squared dh. So our functions here are using the horizontal stripping, so we need to take from, the change is from dy, or the stripping is from dy, or we're going to cut by change dy or dy. Cut it by through this one. This is our dy. This is the width of our cuttings. Okay, the width of our cuttings here, dy. So v is equal to our limit for cutting here is, since that is in terms of y, change of y from 0 to 4 here, because we're going to substitute the value for our 2 squared, that is equal to 4. So therefore our limit from 0 to 4. So pi from 0 to 4, and the first radius is equal to 2. This is the bigger radius 1. The radius 2 that are there. So this is 2 squared minus the radius 2 is x squared. And this one is dy. Since we are going to talk about the change is in terms of dy, so this is x, so we need to substitute what's the value for our x here. So the value for our x is equal, x squared is equal to y. So let's substitute here. So that it would be the same function. Pi is 0 to 4. This is 4 minus, and this is y. And this is dy. So v is equal to pi from 0 to 4. We need to integrate now. So v is equal to pi. This is 4y minus y squared over 2, bound from 0 to 4. So v is equal to pi. This is 4 times 4 minus 4 squared over 2. And this will become 0. The rest, 0. So v is equal to pi. This is 16 minus 16 over 2. And v is equal to pi. 16 minus 8, that is 8. So therefore, or 8 pi. Or approximately, this is 25 8 pi 25.13 cubic unit. Okay, that's a problem number 1. So let's proceed with problem number 2. Find the volume of the solid generated by revolving around about the x-axis, the area bounded by y squared is equal to 4x, y is equal to 4, and x is equal to 0. So this one, if we're going to illustrate this, so the function, this is y squared is equal to 4x, and this one, bounded this one, we need to get the area of this one here. Okay, but it is being revolved, so it generated a solid volume of solid generations or generated. It will, if we're going to revolve that one around x-axis, it will generate a volume of a solid. Right, so we have to use the vertical stripping here. So you need to have the vertical stripping. So if that is vertical stripping, our cuttings is in terms of dx, or the width is in terms of dx, and the height, this one. Since we need to have the volume is equal to pi from a to b, so r squared to 1 dh. So what is our the value for our r here? So the value for r here is the first r that we need to get is this one. This is the r 4. Our r2 is equal to 4, and our r1, if we have here our r is equal to 4, our r1 is equal to y. Here, this is r y. Y. Because if we're going to rotate it, and in terms of dx, So our volume is equal to pi from A to B, and r squared 2 minus r squared. So what is our limit? So our limit is, since that is in terms of x, so therefore from 0 to 4. So v is equal to pi from 0 to 4. Our first r2 is 4 minus r1 is equal to y. This is 4, this is squared, and this is squared. Dh is equal to dx. Since this is in terms of y squared, we have to substitute the value for this one become 4x. V is equal to pi 0 to 4. This is 16 minus 4x. Then this one is dx. So now we are going to integrate now pi. This is 16, all in terms of x, right? So 16x minus 4x squared over 2 from 0 to 4. So our v is equal to pi. Alright. 16 times 4 minus, this is 4 squared minus 0. The rest is 0. Okay, so v is equal to pi. This is 16 times 4, 64 minus, this is 2, right? It's 2x squared. So times 2. So 4 squared times 2, that's equal to 32. So therefore b is equal to 32 pi. So that's 32 pi, or approximately times pi 100.53 cubic unit, or for 32 pi. So that's all about problem number 2. Let's proceed with problem number 3. Find the volume of the solid generated by the area bounded by the curve y is equal to x squared and y is equal to x plus 2 revolving about the x-axis. So this one, if we're going to illustrate, first thing that we're going to do is we need to illustrate. So in checking your paper, you need to illustrate first so that I could figure out. So if you understood the graphing. So this is the illustration. This is y is equal to x plus 2, and the curve is y is equal to this one. The curve is equal to y is equal to x squared. If we're going to take the vertical stripping here, that is from the change of dx. So using the vertical stripping, what is our r here? So our r here is, okay, what is our r? Our r is above minus the lower. So our upper minus the lower, the upper radius is equal to x plus 2, and the lower radius is equal to x squared. So by the use of this one, so area is equal to pi from, since we are talking about here, the this is in terms of dx, so this is from negative 2 to 2. So the here from negative 2 to 2, so that would be our limit, negative 1, rather negative 1 to 2. And our r, so the first r that we're going to use is this one, x plus 2 then squared minus what is our lower. So x squared, then squared, then dx. So area is equal to pi. We need to simplify. So we have here x squared plus 4x plus 4 minus x raised to 4 dx. So area is equal to pi. Okay, we need to now take the integral. So this is x cubed over 3 plus 4x squared over 2 plus 4x minus x raised to 5 over 5 from negative 1 to 2. Our area is equal to pi. We have to substitute. So 2 cubed over 3 plus 4 times 2 squared over 2 plus 4 times 2 minus negative 2 raised to 5 over 5. Then minus, this is negative 1 cubed over 3 plus 4 times negative 1 squared over 2. Then plus 4 times negative 1 minus, this would become negative 1 raised to 5 over 5. Okay. We have to simplify. Area is equal to pi. Okay. What is 2 cubed? That is 2 cubed. That is 8 over 3. 2 squared times 2 squared. 4 times 4. That is divide 2. That is equal to 8. This is plus 8 minus 32 over 5. And minus, we need to deduct this one. This is negative 1/3. And plus 2. That is plus 2 minus 4. And this would become negative 5, negative 1 raised to 5, then negative, this odd. So therefore, this is plus 1/5. So area is equal to, we have to simplify this one. So 8/3, 8 over 3 plus 8 minus 32 over 5 using calculator. This is pi times 184 over 15 minus, this become negative 1/3 plus 2 minus 4 plus 1/5. That is equal to negative 32 over 15. If we're going to subtract this one, 184 minus 32 divide 15, that is equal to, no, so not subtract 184. This is negative plus 32, 216 pi 216 over 15, or simplified as 72 over 5 pi. The volume, rather, the volume, not the area. Okay. Okay, the volume. All right. The volume. Okay, the volume is 72 over pi, 72 over 5 pi. Or that is 72 divide 5 times pi divide 5 times pi. Approximately, this is 45.24 cubic units. Okay, this is V rather, not the area. Okay, V. Let's try this. Find the volume of the solid generated by revolving the area bounded by the curving curves about the indicated axis of revolution. So y is equal to x squared, x is equal to 3, y is equal to 0 about the y-axis. And number 2, x plus y is equal to 14, x is equal to 2, y is equal to 2, and about the x-axis. So try this at home, and you have to pass or submit this one during our class. I will be collecting this one. Thank you, and God bless everyone. Thank you for listening.